Previously we talked about the interface and showed an example of a batch kiln simulation. In this video we will show an example of a longitudinally fed progressive or continuous kiln and a transversely fed progressive kiln. I have already created a setup file for the longitudinally fed progressive kiln, so we are just going to go to Load Setup. There is the setup file. We open that. You can see the file name in the bottom panel, but we still have to render the kiln layout. Then we get this setup where of a longitudinally fed progressive kiln where I chose progressive here and longitudinally fed here. I also chose 4 transverse and 8 longitudinal stacks. In the Lumber Properties tab we chose this much content distribution, which is more or less normally distributed, and in the Drying Process tab I created this temperature regime for the kiln. You can see there are 4 steps of 15 hours each, and the graph shows the temperatures and the air speeds for each step. I chose a low target moisture content of 10%, essentially moving the target moisture content out of the way, because I want the lumber to move through all 4 steps fully without the simulation stopping. And then I set the target end time to 60 hours, which is 4 times 15, so these 4 15-hour steps yield a total of 60 hours. Then we can move on and start the simulation. Now, in the horizontal temperature profile you will see that we have this jagged temperature profile, and that's because we have reheat elements in the middle of the kiln. The surface stress evolution shows that the driest boards are approaching a high surface stress while the wettest boards have not started to develop any surface stress. The moisture content is moving quite quickly to a lower level. The within-board moisture content profile shows that we are approaching, and now we are at 53 hours already. There we reached the end of the simulation at 60 hours. The average moisture content is 13.5%, but the deviation is quite large. So this schedule will have to be improved to yield better results. This surface stress evolution shows that the wettest boards actually reach the highest surface stress levels, and you can see on the horizontal moisture content profile that we have a low moisture content close to the reheat elements and on the outside of the load. The moisture content distribution shows that there are some boards that are too wet. And that is how simulate a longitudinally fed progressive kiln. Now we can go back and set up a transversely fed progressive kiln. We can select 2 drying zones, and in the first drying zone we select an airflow with the feed. Now the number of transverse stacks in the first zone we set at 4, and the total transverse stacks we can set as 12, so that we have 8 stacks in the second zone. The number of longitudinal stacks we set as 1. Now we can render the kiln layout, and this is what we get. So these stacks would be fed from here on the left where it says entrance. They would be fed from left to right with the exit here on the right-hand side. The airflow is with the feed in the first zone and against the feed in the second drying zone, meeting in the middle. We can keep the same lumber properties. The Drying Process tab looks very different for this type of kiln. We have to provide a feeding interval instead of a schedule, and start at 80 and 60 in Zone 1, and then have 85, 60 in Zone 2. Okay, let's see what happens if we start the simulation. We only see one package. This is the package we are going to follow, package number 1, the reference package. It already moved to the second position now. I'm just going to pause it here. You can see the overall summary graph. These curves describe the temperatures and the status of package number 1, the reference package. This is the only one package we are following. But we have to have other packages coming into the kiln because the airflow is from left to right here. So the evaporation and temperature drop over these first packages influence what temperature the reference package experiences. You can see the wet bulb can go down a little, and that's because the new packages entering the kiln are cold. Right, we can resume the simulation. And now you see this text coming up, pre-run for Zone 2 in progress. Because the air is going to flow from right to left in Zone 2, we have to have packages in front of our reference package. So we populate the second drying zone with packages that have similar properties to our reference package at the end of Zone 1. And we run that for a while until it reaches a steady state. And then the simulator will know which temperatures our reference package is going to experience. And then the simulation can continue from that point. Now the reference package will move to the second zone. So we will have to scroll to the right to keep on following the simulation. This pre-run can take several minutes to complete. And then we will have to scroll to the right to keep on following the individual board moisture contents. So now the pre-run is finished and the reference package has moved to the next position, that is the first position of the second drying zone. Now the reference package starts on the leeward side of the second drying zone. And you can see the second drying zone is populated with pre-run packages. And package 1 is to the left here following them out of the kiln. And the air is flowing from right to left. You can see on the overall summary curve what the entering air temperatures that this package is experiencing at each point in time. The simulation is almost finished now. There we are. So we got a final average moisture content of 24.8%. You can see how the moisture content changed. And if you look at the surface stress evolution, the driest boards in the reference package had a high surface stress in the second drying zone. So one would make a change to dry the lumber more aggressively in the first drying zone to have better conditions towards the second drying zone and to get a lower final moisture content. Remember that this temperature profile is only over the reference package. So there is not a very large temperature drop. Each plot point represents one board column in the reference package. And this is the moisture content distribution in the reference package, package 1. The within-board moisture content profile shows that the wettest boards in the reference package are still quite wet. And the stress level in the driest boards is quite high. There is a large tensile stress at the surface and a compressive stress at the core. And that is how we simulate a transversely fed progressive kiln, and how we interpret the graphs. Of course, there are more kiln variants that can be run. You can select only one zone. You can select to have a different air direction. For example, with the air flow towards the entrance. In this case, the simulation will start with the pre-run to find the steady state. And so you will have to wait a while before you actually start seeing graph updates and get a depiction of the individual board moisture content. And that concludes the demonstration of how progressive kilns can be simulated. Thank you for your attention, and I hope you find the simulator useful.